the change. Okay, it's a strain induced.
What's the 0.005 thickness underneath it for then?
Which one?
So
This
underneath
one?
the answer.
Oh,
under the, yeah.
This is the plate thickness of 0.05.
So why do we need that for the strain?
Just to tell you, if the thickness is at 0.05, the thickness, the strain induced is 0.146. Now I change the plate thickness to 0.03.
Okay.
Okay.
All right. Yep.
So when this happens, okay, our delta C will be plus or minus 2.34 times 10 to the power minus 3. Okay. So from here, the strain induced, same formula, delta C divided by C, C naught, okay, circumference outside. So circumference outside, sorry, it's not circumference outside, 0 point is Cn, I do apologize. So this is equal to 2.34 times 10 to the power minus 3 divided by 0.0274. So this will be equal to 2.34 power minus 3 divided by 0.0274 is equal to 0.085 strain with 0.003 millimeter thickness or meters thickness. Okay. So you can see by changing the thickness, your strain has been what? Reduced. But you have to be really careful. You cannot say, why not we go as thin as possible? Yeah, we go thin as possible. You design a structure that's like Coca-Cola can. It will buckle, yes or no? Okay, so what it states down, what you can see down here, unfortunately, we cannot change the radius. Okay, so the strain induced is controlled by the outer radius and the thickness of the plate. So I know for the fact this company now has an algorithm now to help them. Once the design is finalized, they can start adjusting what? Adjusting the parts to ensure that the strain induced is small enough that they can bend it, okay, for manufacturing. Okay, so this is the outcome of knowledge like this. Okay, if you will not know, right, you will use a very thick plate, then what will happen? Oh no, okay, you find very difficult to what? Strain. Okay, or if you use too thin, what will happen? Okay, nothing good will happen. Okay, the thing will buckle. So in summary, what we have learned for the past 5 weeks, I think 5 weeks, okay, is the integration of different discipline subject. Okay, so in summary, right, in summary, if we look for foosball, we found that we have to purchase with perlite plus ferrite due to low strain hardening behavior. Right, we purchase them. Then we heat to single phase austenite, right, which has FCC, easy to what? Deform, right? We realize that, right? Right? And temperature to reach single phase austenite is lowered with manganese, right? That's why we could do it. And finally, quench to room temperature to transform austenite to martensite. So this is how we process, right? And you guys will have all the knowledge, all the keys behind you. For dual phase steel, from all these 3 case study.
Hey, Eugene.
Yes.
So did we change from TRIP to US4 because of that analysis you just did?
No, I'm just doing a summary.
So why are we introducing that new material?
That was last week's case.
This is last week.
Okay, all right.
Okay, I'm just doing a summary on what is going on since week 1 to week 5. And when I write all this, you will understand why, right? And then we just do today is dual phase steel. Okay, dual phase steel. You have to control the holding temperature.
¿Qué?
Before.
¿Qué pasa? You didn't even do your exercises today, mamá. El hombre me dijo porque si tú estabas haciendo tus exercises hoy.
Sorry, I have to mute someone, okay? Okay, sorry. So you have to control the holding temperature before quenching. Okay, so like what we have mentioned before, so we have to ensure that material are processed in smaller batches. Have multiple sensor in furnace and holding temperature has to be within a specific range. Okay, so that's what we know about dual phase steel, and why this solution is dual phase steel microstructure is sensitive to temperature change due to the low percentage of carbon. Okay. Let me elaborate why the low percentage of carbon. So if you look at the phase diagram, I just realized this. If you look at the phase diagram, okay, so this is percentage of carbon. This is your 726 line. Okay, so if this is 0.77, right? Then this is your, I mean, I should have drawn it to scale, but this is, so this is about 0. I could not remember now, 0. Percentage of carbon. I think it's 0.123, right? The range over here, or if you go the range, right, with temperature, right, you see this range over here, the distance of the gap is not so far. If it's at 0.5 or not 0.5, if it's somewhere around here, right, the temperature range, right, this range will get bigger and bigger, so it's less sensitive. But because of its low percentage of carbon, right, it's more sensitive to temperature change. Okay, so that is for dual phase steel. And finally, for trip, for trip, $800 is you have to control the geometry of the raw and processed material. Okay, processed material means after manufacturing. Okay. Once you can control them, then you can process TRIP 800. Okay, because, and always remember for TRIP, the manufacturing strain induced has to be small. Okay, if it's too big, you're going to face a lot of trouble. Okay, as promised, that's all I have now. Okay, and this is where I will test you